Hello everyone, today we'll be talking about NoSQL databases. So what is NoSQL? NoSQL means not only SQL or non-SQL. So it refers to the databases where we do not use our traditional tables or relations like SQL databases. Here we are using different data models to store the data, which is more flexible and it is used to handle very large volume of data. So why are we using the NoSQL? Because we can handle very large volume of unstructured or semi-structured data. In SQL, we are handling structured data, which means we are storing the data in the form of tables, which includes rows and columns. And SQL has a fixed schema, but then our NoSQL has a very flexible schema, which means we can enter different types of data, which is the unstructured data, and it is ideal for handling big data and real-time analytics. Some key features of our NoSQL databases are dynamic schema, which means it can handle multiple different types of data. Then horizontal scalability, which means if the database can't handle many users, we are just going to add a new server into it to this databases, and then some of the users are going to be diverted to that server. So we are using multiple servers to make up one database. High availability and fault tolerance, in the sense that since this database system is made up of multiple servers connected together, even if one or two server fails, the system will be available to the users. And then fast performance for massive datasets. It supports document key values, columns, and graph models. This is the way we are storing the data in the NoSQL database. Next, we have some challenges. Lack of standardization. As we have said before in the features, it uses multiple different data models. So for each model, we are going to have different query language to work on the model. So that is why we can't have one standard query and then which is working for each and every model. So that is why we have a lack of standardization. Limited ACID compliance. ACID means atomicity, consistency, isolation, and durability. This is the model which we follow in our SQL or our structured databases, which focuses more on the consistency and the reliability. But here in our NoSQL, we are focusing more on the availability of the data. So there is a limited ACID compliance. Then weak support for complex query. As NoSQL databases are useful for our quick lookup or searching, but then it has some difficulty in handling our complex queries. High management complexity, in the sense that these multiple servers are combined together to form one database, so management is going to be a little bit complex. Less mature than traditional RDBMS. So it is a newly launched software compared to the RDBMS, so it is less matured. So here is some difference between our SQL and NoSQL based on the data model, schema, scaling, consistency, and then what is used for. Scaling, in the sense SQL is vertical scaling. We say that here we are increasing the storage or the RAM capacity of one specific server to scale, but in NoSQL we are adding multiple server to the system. So this is the difference between vertical and horizontal scaling. And consistency, SQL follows the ACID model, and then NoSQL follows the base model. Here are some types of NoSQL databases: document-oriented, key values, white column graph databases. Then we have our document-oriented. Here the data are going to be stored in documents like JSON. So and then each document is going to have a field and value pairs, and then it can also include some arrays or nested objects. So and it is great for semi-structured, such as our user profiles and product catalog. It is very flexible, and each and every document can have different structure. Like, let's take an example here. We have our ID. ID is an integer. Name is a string, and then email we have another string. Address, here this address, inside the address we are having another object, that is street, and then the city. So this is the nested objects. And for hobbies we are having this music, guitar, and reading. These are our arrays. Next we have the key value data pairs. Here everything is going to be stored in a key and a value pair. The key is going to act like the unique ID, and then the key can be of any type of data, that is the string or object or numbers. Then it is very useful for simple lookup, caching, and session management. Here example, we have the key is user1234, and then the value is the name, email, and the designation. So this is our one example of the key value database. Next, we have white store column. Here we are storing the data in the form of the columns, but then for each and every row, we are going to have different columns. Let's say we are storing the data. We'll see it is good for handling large and sparse data set for analytics. We see an example here. In the SQL table, we have predefined attributes, and in that attribute, each and every record needs to have the same value for each and every column. But when we are looking for the white column store, one user can have two columns, the next user can have three different columns not related to the first column. That is the flexible schema. So there is a difference between our SQL and the white column store. Next, we have the graph database. So here we are going to have two points. That is the nodes, that is going to be your entity, and then the edge, that is the relationship. This type of database is used when the relationship between the entities is the highest priority. So it is used for social network and fraud detection, or simply a recommendation system. So an example is we are having the node, that is the entity, and then the edge, that is the relationship. So we have three entity, that is Alice, movies, and Inop. So Alice follows is the relationship. Alice follows up on movie, that means he watches a lot of movie. Then Alice likes Inop. So Inop is something that Alice likes, but we don't know what Inop is. So now again, Inop is movie. So now we can see that Alice likes movies and Alice likes Inop, and then Inop is the movie itself.